Hello everyone. In this video, you will learn about the reflection of plane waves in a ripple tank. Here we have three new terms: reflection, plane waves, and ripple tank. By the end of this video, you'll of course get familiar with those terms. So let us start. Waves are energy carriers. They often carry energy from one place to another. If a wave travels through a material, such in the case of water waves of the sea or air sound waves, the particles of the material will be distributed by the wave, but not carried along with it. Some waves, such as electromagnetic waves, do not need a material to travel through. Waves we get from the sun are 150 kilometers away, and they travel through an empty space, giving energy to the surface they land on. Here is one type of ripple tank that is used to show how waves in water usually behave. So basically, the water is contained in a plastic frame with a glass bottle. A wooden beam is suspended from a wooden bar, can be raised or lowered. A small electric motor fixed to the wooden beam allows it to vibrate when the motor runs. The dipper touches the water surface, giving circular waves across it. So, when the dipper is removed and the wooden beam is lowered to touch the water surface, straight waves, that are also known as plane waves, will move across the water surface. Consequently, we will not have circular like waves. In the following slides, we will see the difference between plane and circular waves. The lamp here projects a picture of the moving waves onto the piece of paper under the ripple tank, and the crests of the waves appears as white lines. Here we can see water from the ripple tank magnified from the previous slide. Okay, so when the wooden beam is lowered with its dipper ball not touching the water, and the motor is turned off as well, we will notice a series of widely spaced plane waves that will move along the water surface. So, as a result, when we remove the dipper ball, we obtain plane waves. However, if the dipper ball is touching the water, it will present circular waves. Let us see what happens when the wave crests move and strike a reflecting surface that has been placed in water, such as in this case a metal strip. Think for a second. Which way are the reflected waves moving? Yes, the answer is downwards across the original wave. Now, let's select multiple waves. Notice how the top end of the wave folds and reflects downwards. The rest of the wave moves forward. We're seeing a stream of plane waves moving across the water when the motor on the wooden beam is running. So, the motor is generating multiple waves. However, the dipper ball in this case is not used. In order to obtain a stream of a series of plane waves instead of circular waves, notice how the reflected waves move through the original waves and see the directions. So before reflection, the original waves are moving forward, then they encounter the metal strip, causing a downward reflection of the waves. The distance between the wave crests is usually called a wavelength. Now, let's see who will figure out this question. How would you make the ripple tank produce waves of smaller wavelength? Yes, of course, by making the motor run faster so that the wooden beam vibrates more frequently. Here we have some tips to remember. The waves reflect when they encounter a boundary, For example, metal strip. The plane waves are straight waves, and the wavelength is the distance between the wave crests. Thanks for watching.